welcome to the fourth session on Subspace Topology. As I said in the last lecture, today we will be looking at interaction between continuous maps and subspace topology. I do not know whether I would be able to finish whatever I want, otherwise it will spill over to another one. Okay, let us go ahead. Yeah. So this is the title of today's lecture, Subspace Topology 4, delivered on 11th Jan. And YouTube channel is here. You can download the list of my videos from this here. Okay, search for list of videos. And I hope to periodically, at least on monthly basis, update this. Because the reason is the YouTube way of listing the videos is very difficult. If you want to learn some subject, okay, you do not know where to start, what is the next video, okay, here in the list, each topic wise I had given the order in which you have to watch the videos. So it will be very useful for a beginner if you want to learn. But if you just want to have some kind of reference, you can just go to any place. Okay, so let us start with our work. The first thing is, so suppose X tau is a topological space and A is a subset of X, and let tau A be the subspace topology on A, right? Suppose I have a continuous map from X tau, let us say tau X, to Y tau Y. This is a continuous map, or let us say continuous at A in A. Okay, this is as a map from X tau X to Y tau A. It's continuous. If you want, simply say it's continuous on X. Okay, many of the students have problem with continuity at a point. That's what I find. Okay, but if you watch my videos, you should have no problem. But this is okay, continuous on X. Now I can restrict F to A. So this is my X, this is my Y, and this is my A. Okay, so this F I am restricting. Okay, to A. Call this, we want to call it as G. Okay, now I have a map. What kind of map I have? I have a map G, that is F restricted to A, from the topological space X tau A to Y tau X. You understand that? What I know is F is a continuous function from X tau X to Y tau Y, but now when I restrict it to A, I have a map from the set A to the set Y, but the set A has now a topology, namely tau A, the subspace topology. So what is the question I can ask? The question I can ask is G, that is when restricted to F restricted to A continuous. Okay, it is more important to understand the question because the answer is very easy. Okay, please listen to me. Okay, this is very important. Okay, right. To check continuity of G, what should I do? So take any V in tau of Y, then I have to look at G inverse of V, whether it belongs to tau of V. This is what I have to ask to check continuity. This is G, not F. My handwriting is not good. Okay, right. So let V belong to tau of Y. Let us look at G inverse of V. What is G inverse of V? This is set of all A in A. Remember, G is a map from where? A to Y, right? Therefore set of all A in A, so that G of A belong to V, right? But what is G of A? This is nothing other than set of all A in A, so that F of A belong to V, right? Now this is a subset of Y. Okay, you understand? So when does an element belong to this subset G inverse of V? When does A belong to this? If only if A must be an element of A as well as f of A must be in B. Therefore, this is nothing other than A intersection with F inverse of B. You understand that? Right. Now, what do I know about this? Since F is continuous from where to where? It is continuous from here to here. Therefore, B is here. Therefore, F inverse of B will be in tau of x. Yeah. Therefore, this is an element of tau of x, and this is an element. Therefore, this element, the whole thing, is an element of tau of A. Okay, this belongs to tau of x. Right. Therefore, what do I have shown? I have shown that G inverse of V is in tau of A. For any arbitrary open set V in Y, G inverse of V is open in the subspace topology of V. So therefore, we conclude the restriction of a continuous map F from x tau x to y tau y to a subset A is continuous. See, notice that this fact, this and the next fact which I am going to say, you will be using throughout your life whenever you use subsets are okay, because you will be using subspace topology. But people always assume, because of real analysis etc., you immediately assume it should be true, but very rarely students or teachers make you or allow you to check these things. Okay, so pause, review, proceed. So let's go back to the proof. So how does the proof look like now? So I have an open set, okay, V here, then this will be my F inverse of V. Okay, that is belong to tau x, therefore I am going to look at only this intersection. But that's going to open in tau v. That's the picture I had. Okay, so pause, review, proceed. And the second is that I want to prove something very interesting. Now suppose I have a x tau x, the same thing, and y tau y. Okay, so let us assume this, and f is a function. Right, now something very interesting happens. Let me assume this is okay. So let me start it. This are topological spaces, and let B be a subset of Y, and let tau B be the subspace topology on B. Right, so this is a picture I have. This will be my Y, and whereas this is my B. Okay, and I have my F. This is my X. Right, what I would, therefore I think of this function F. Actually, where does it land? I should write it. It lands only here. Okay, so I have function F from x tau x to b tau b. Okay, I want to know when this is continuous. Okay, and you will say that's obvious. Between two topological space I have given a map, so you know how to check continuity, right? This is where something very interesting happens. Okay, now remember this F, I can think of actually, I can think of F as a function from x to y tau y. The only thing is f of x, f takes values only in B. F as from x to y taking values only in B. You understand that? So look at the picture. Originally this fellow was not there at all. This was not here. Okay, what I have is x, this blue to this green B, and Yep, that's all I had. Now what I want to do, the same thing I am looking at as a x2. Since B is sitting in Y, I am thinking of it as a map from x to Y. Right? Now what is this? See, B is a construction, a new construction, right? We gave a subspace topology. It was constructed from the topology on Y. So tau B is a new construction. Okay, so I want to know when the function f from some space x to a newly constructed space B is continuous, right? But I am thinking of this function as a function from x to y, but taking values only in B. Please, these are the things which are never explained. Please listen to me. This is actually one of the most important properties, and these two facts you will repeatedly use throughout your life if you stay in mathematics, of course. Okay, so I am going to say, let us call this as a G. Okay, what is g of x? G of x is nothing other than f of x for every x in x. Okay, then so that you know the result I want to say is this, then f is continuous. Let me write f from x tau x to b tau b is continuous if and only if g from x tau x to y tau y is continuous. Remember, g is nothing other than f. Yeah? Okay. Is the statement clear? As I said earlier, it's more important to understand the subtlety of the question. The answer is extremely easy. Okay? So you might have seen more often I make you, or rather I ask you to understand the questions, because questions are the more important one. They are the one which open new vistas, okay, new discoveries, new inventions. They lead us to such things, okay. But our usual exams only emphasis on answers, but learn to ask questions. Okay, so this is the question. The answer is very easy. Okay, suppose f is continuous. I want to know whether g is continuous, right? For prove g is continuous, what should I do? Start with a v in tau of y. Then I want to know whether g inverse of v belongs to tau of x. Is that clear? Yes? Yeah, okay. But what is g inverse of v? Remember, this is a subset of x. Therefore, start with any x. Then x belongs to g inverse of v when if and only if gx belongs to v. Right? But what is this? Gx is nothing other than fx. Fx belongs to b. But remember, f already takes values in b. Right? Therefore, this follows fx lies in b intersected with b. Do you follow that? I just want you to understand this is all set theory, very easy functions and set theory basic stuff, right? So what I'm claiming is g inverse of v is nothing other than, can somebody tell me? F inverse of v intersection b. This is all I am claiming. Okay, this means what? X belongs to f inverse of v intersection b. Yeah. So if I start with x in g inverse b, I proved x belongs to f inverse of v intersection b, right? So this one is I proved. Okay, pause, review, proceed. Now conversely, let x belong to f inverse of v intersection b. Then I want to know whether x belongs to g inverse of b. Right? Is that clear? Okay. But you can just simply repeat the proof. So x belongs to f inverse of b. What does it mean? That means fx belongs to v intersection b. Right? But for x, this is same as gx. Therefore, gx belongs to v intersection b. Right? But remember, this is not a condition. This means gx must be in v as well as in b. Right? But my f takes values from, this is same as saying fx belong to V. Why? That's because fx always lies in V. So that's not a condition. Do you understand? Fx belong to V intersection B means fx belong to V as well as fx belong to B. V and B sound similar, right? Especially if you are from Bengal. Okay. Alright? Okay. So fx belong to V. But fx is nothing other than gx belong to V. But that is same as saying x belong to G inverse of V. I just kept these things f and g separately instead of say using the same symbol f, so that you should think of that as a function from g as a function from x to y, but it takes values only in B. Okay. So what do you think I have proved? I have proved that G inverse of V is nothing other than f inverse of V intersection B. Now what do I know about f? F is a function from x tau x to B tau B. This is continuous, right? Now what do I know about V intersection B? V intersection B is in tau B because V is in tau y. Therefore V intersection B is tau B. Therefore f inverse of that will be in tau x. So this is in tau x. But that is nothing other than G inverse of V. Therefore I have proved G inverse of V is in tau x. That means G, if I consider as a map from x tau x to y tau y, where G equal to f for all x, okay, and f of x is contained in B. Okay, this is continuous. So f continuous implies G continuous. Okay, pause, review, proceed. Do not get confused, these are all extremely easy. Okay, except people don't teach such things. Remember, many times, how many times you use f is a function from R to R, but f takes values only in the positive real, so let us say. Then you want to think of this as a function from R to 0 infinity, and you want to say it's continuous. This is continuous, but then you want to think of it as a function from real variable, function of a real variable. You understand? F is a function from R to 0 infinity. Okay, it takes only positive values, and it is continuous. But then I want to consider f as a function from R to R. Okay, then it's continuous. Conversely, f is a function from R to R, takes values only in 0 infinity. Then I can think of it as only as a function from f from R to positive reals. Positive reals with subspace topology. Yeah, so I want to say these are continuous. Keep that point. As I keep repeating, it's very important to understand the subtlety and the question. Now let's look at converse. Let G from x tau x to y tau y continuous. Well, what is G? G is nothing other than f. Okay, and that f of x is B. Okay, then let's look at f, the original map f tau x to B tau B. I want to know whether it is continuous. So f is given, G is gotten. So I said if f is continuous, I proved G is continuous. Now converse. Consider the f as a map from x tau x to y tau y. That is continuous. Then if I consider as a map from x tau x to B tau B, is it continuous? Okay, if you don't like G, think of it this way. Right? Yeah, so f from x tau x to y tau y. Okay, so that f of x is contained in B. Then then f from x tau x to y tau y is continuous if and only if I consider this f as a map from where x tau x to B tau B is continuous. If you don't like G, this is what I want to do. This is how you should remember. Let's look at the example. F from R to R, but takes only non-negative values like f of x equal to e power x or f of x equal to x squared plus 1, some such thing. Okay, right. Now what is that I have to prove? So converses, this is given, G is continuous, that is f as a function from x tau x to y tau y is continuous. I want to know whether f is continuous. To prove f is continuous, what should I do? Okay, start with the u, okay, w in tau of b, f is from where to where? X tau x to y, sorry, b tau b, right? So I want to know that this is continuous, therefore start with the w in this, right? But since the w is in b, this means there exists a v in tau y, so that w equal to v intersection b. Do you understand that? Yes? Okay. So what is that I have to check? I have to check, to check the continuity of f, I have to check whether f inverse of w is in tau x. Yeah? But what I am claiming is f inverse of w is nothing other than, okay, g inverse of b. That's it. Do you understand that? Please remember, if you want, it is f inverse of v. Okay, I hope you had been struggling with me for a long time, then you would know. Okay, I always try to push somewhat subtler and somewhat hard, difficult results also, because that's the only way we can improve. Is it clear? But this is okay. Why? Suppose x is here, that means fx is in b, fx is in w, right? But what is w? W is v intersection b. Remember, f is a function from x to b, therefore fx belong to b is not a condition, therefore this implies fx belong to b, right? But what is fx? Gx, that means gx belong to b, that means x belong to g inverse of b. Okay, I don't want to repeat. If you want, pause, review, proceed. If you want, rewind and go through. So what I have shown is f inverse of w is contained in g inverse of b. Now let's x belong to g inverse of b. That means gx belong to b. But that means fx is in b, because gx is nothing other than fx. Fx is in b. But remember, fx always in b. This is already known. This is a given hypothesis, right? Therefore, this implies fx belong to b intersection b. But that means x belong to f inverse of b intersection b. But that is x belong to f inverse of w. Yeah? So I have proved g inverse of b is a subset of f inverse of w, right? Therefore, we have proved f inverse of w is nothing other than g inverse of b. But what is our hypothesis? Hypothesis is g is given to be continuous. I want to know whether f is continuous, right? So I start with the subset w in tau of b, then I have to check f inverse of w is in tau of x. Okay, but I found out f inverse of w is nothing other than g inverse of b, where b is such that b could be anything, such that w is b intersection b. But f inverse of w is nothing other than g inverse of b. But g is continuous, b is in tau y, therefore this is open in tau x. Therefore this is in tau x. Yeah? Please pause, review, proceed. So these two facts are usually not done, okay, or they may be there, but teachers or books do not make a very conscientious effort to bring them out. They are very beautiful. Forget my notation G, F, etc. The basic idea is simple. What is the first fact? These are the two facts we will always use about subspace topology. So F is a function from x tau x to y tau y. This is continuous. Therefore, if A is a subset of x, the restriction f as a map from a tau a to y tau y is continuous. Okay, intuitively restricting a continuous map to a subset is continuous, but with what the topology of the subset, that's a subspace topology. That's fact 1. Okay, what's a fact 2? This is something very interesting. It's a counterpart. What is the counterpart? Now think of this f as a function from x tau x to y tau y, so that f of x is contained in B, right? Then I think I can think of f as a map from x tau x to B tau B, right? Then what do I say? This map is continuous if only if this map is continuous. That's it. Yeah, very, very beautiful. So if I want to check what is advantage, remember B is the subspace topology. Okay, then I have to check continuity of f from x to B. But what it says is, don't worry, think of it as a map from x to y, but taking values only in B. And do you know the continuity of f from x to y? Then you are through. Okay, this is called the universal mapping property, actually. Okay, this is universal mapping property of subspace topology. This is never done in any textbook. What does it say? Okay, UMP. Those who have seen my lectures on unified view on subspace, product and quotient topology would already seen it, but okay, in case you have not seen, this is what it says, right? So let B be a subset of y and y tau topological space. Okay, then f from x tau x to b tau b is continuous if and only you consider f as a map from x tau x to y tau y. This is continuous. Okay, this is the theorem which I proved just now. Okay, all right. Okay, right. Now I want to say something very interesting. Let us stick to A then. X tau x A, right? Now do you know that I have a natural map, the inclusion map of A to X, namely A going to A itself. That is, this J is nothing other than identity map on X restricted to A. Yeah, right? Now let us look at some tau dash is a topology on A, so that the map, the inclusion map A tau dash to x tau x is continuous. Tau dash is any topology, not necessarily subspace topology. You understand that? Okay. Then what does this say? This says that therefore if I start with any u in tau of x, then J inverse of u must be in tau dash. Okay, but what is J inverse of u? J inverse of u is set of all A in A, so that J of A belong to u. But this is same as saying A in A. What is J of A? It is A belong to u. Okay, therefore when does an element belong to J inverse of u? It has to satisfy two conditions. The element must be in A as well as it must be in U. Therefore this set is nothing other than A intersection U. Do you understand that? Please pause, review, proceed. Yeah. So what did we do? So J, I have a topology on A, so that the inclusion map x to tau x is continuous. Then what did I find? Then I found for every u in tau of x, u intersection A is in tau dash. But for every u in tau x, u intersection where does it belong to? It belongs to tau A, right? And all elements of tau A are of the form. Therefore, what is that you have concluded? You have concluded tau A is contained in tau dash. So please, these are never done in usual topology course, but if you are going for higher studies, you will really appreciate this kind of thing. And after these things, if you want, you should go back to my unified view on various constructions. This will be again explained there. So what do you think I have proved? I have proved that, okay, if tau dash is any topology on A, making the standard natural inclusion map of A into X continuous, okay, then that topology is finer than the subspace topology, right? So what does it mean? That means among all topologies tau dash on A, which makes this inclusion map continuous, tau A is the smallest. Do you understand that? Because every tau prime which makes J continuous contains tau A, right? Now, do I know this is continuous? Next question is whether this is continuous. Is this continuous? Of course it is continuous. Why? Start with u in tau x. Then as I said, what is J inverse of u? That is u intersection A, therefore it is in tau A, right? So please understand. So tau A makes this function J from A tau A to x tau x continuous. Not only that, if tau prime is any topology on A, so that this map A tau prime to x tau x continuous, then tau A is coarser than tau prime, that is tau prime is smaller. Therefore the final conclusion, tau A is the smallest topology on the set A, which makes the inclusion map A, J from A to X continuous. Okay, I know this will be tough for somewhat, I'm sorry to use the word, somewhat weak students possibly, but please, the only way you can become strong student is do this kind of thing. See, if you are weak, then what do? You do physical exercise so that you become strong, right? The same way here. Okay, so just because you don't understand, don't give up, try again. Okay, right, so let's go back. So what I have shown today, I proved only three things, but each one of them is subtle. The first two facts are always used. What is the first fact? If f is a function from x to y continuous, restriction of f to any subset A with subspace topology, then I can consider as a map from A with subspace topology to y. That is continuous. That's fact number one. Remember how many times you will use it. Okay. Second thing is, think of a function f from x to y continuous. Okay, x to y, and assume f takes values only in B, right? Then I can think of it as a map from f from x to B, right? Now I can f from x tau x to y tau y is continuous if and only if I think of this as f from x tau x to B tau B is continuous. Okay, please don't be mesmerized by my words. Think carefully to keep the picture in mind. I have x, I have b and y, and I have b inserting, and from x it only goes here. Therefore I can think of this as a map from x to y but takes values on B. Therefore, I can think of a map from X to Y, whether it's continuous, and I'm saying it's continuous only from X to this. I consider as a map into B with subspace topology continuous, right? And what is the third fact I proved? Third fact I proved is consider A as a subset of X, a topological space. Now you have natural inclusion map, namely identity of X restricted to A, right? Now what I said is look at this J as a map from A to X. Now I want to look at the topology tau dash on A which makes J continuous. Then what I said is if tau dash is a topology on A which makes the inclusion map J continuous, then tau dash will contain the subspace topology, and the inclusion map from A with subspace topology to X with tau X is always continuous. That also be proved. Therefore, what was the conclusion? So we have found something very, very interesting fact about subspace topology which is never explained. So what is that? Namely, the subspace topology is the smallest topology on A which maps the inclusion, which makes the inclusion map J from A to X continuous. Okay, please go through these things. Okay, if you find it abstract, review it, and as I keep saying, always watch it with your friend and discuss among yourself. You will learn it much faster. Okay, I hope even though it is challenging, you enjoyed it. Take care and stay safe. Hi, I forgot to add something. As you might have noticed, I'm using a different headset which also serves as a mic. Okay, I'm just using this. Please let me know the audio quality of this particular lecture. Okay, so that I will know whether I should continue with this or I should change it to my earlier headset. Okay, thank you very much. I hope you will mention that in your comments or send me an email. Okay, thank you. Bye.